Now let's look at rates of change. You remember from pre-cal that a rate is a distance over time. This is what you're used to seeing. And one application of derivatives and rates is in physics, where they're discussing average velocities. Now there are a lot more applications, including population growth, flow rates. There are economic applications as well. But you are going to need to know the specific physics applications, like average velocity. So the average velocity is just the change in distance over the change in time. And you can always check your units. That will help you out. Your position will be in a distance, meters or feet, and the time will be in seconds or hours. And velocities or speeds are in meters per second, that sort of thing. Now, suppose I wanted to find the average velocity of a ball that's falling. And I give you the position function right here. The position is minus 16t squared plus 100. All right, and they tell me that t is measured in feet, s is measured in feet, and t is measured in seconds. Find the average velocity over the given time intervals. So let's look at this first time interval. If this is from, we're just going to call this 1 to 2. All right, how would I find the average? Well, the first thing I need to do is find s at 1. So the position at 1 is negative 16 times 1 squared plus 100. So this is 84. S of 2 is negative 16 times 2 squared plus 100. My thing is crooked here. So this is 36. So for the first one, delta S divided by delta T is equal to S evaluated at 2 minus S evaluated at 1 divided by 2 minus 1. So this is 36 minus 84 divided by 2 minus 1, or negative 48 feet per second. Now, if we give you units, you do have to use them. What about B from 1 to 1.5? Delta S, I guess I have my increments wrong there. I already have S1 is 84. S of 1.5 is minus 16 times 1.5 squared plus 100. And that is, let's see, it is 64. So delta S divided by delta T is equal to S at 1.5 minus S at 1 divided by 1.5 minus 1. So plugging this in, you get 64 minus 84 divided by 1.5 minus 1, where you get minus 40 feet per second. Now I'm running out of room on my board here, so I don't want to necessarily show each and every step. Here we go. For C, I know you can't see it, but the interval is 1 and 1.1. So again, S of 1 is 84. S of 1.1 is minus 16 times 1.1 squared plus 100. And this one is 80.84. So delta S over delta T is equal to 80.84 minus 84 divided by 1.1 minus 1, or negative 33 0.6 feet per second. Now, that it's negative shouldn't bother you. That just tells you that it's moving downward. Now, another physics concept you need to get is that velocity is the derivative of your position function. So this is the generalized physics formula that you get in class, and you're told to memorize it. Your teacher may derive it for you using your pre-cal skills. But let's take the derivative of this. Now remember, g is a constant, v naught's a constant, and s is a constant. We're taking the derivative with respect to t. So s prime of t is equal to 2 times 1/2 g t plus v naught. That last term goes away. So gt plus v naught is s prime of t. Now, you have probably seen the formula. V is v naught plus gt. That's simply a way to rewrite this equation. So, suppose I give you the formula. I tell you that a diver is jumping off a platform that's 32 feet above the water, and his position is given there, where s is measured in feet and t is in seconds. When does a diver hit the water? Now, you do need to be able to interpret these questions. It hits the water when your S position is 0, because he's starting up high. So he hits the water when S of t is 0. So when negative 16 t squared plus 16t plus 32 equals 0. So we can factor this. Negative 16, t plus 1, t minus 2 equals 0. So t has to equal negative 1 or 2. Now you do have to do a little common sense here. We don't have negative times. Time is always positive. So the answer is t equals 2 seconds. B, what is his velocity at impact? What we're asking is at t equals 2, we need to find the velocity. So first thing we have to do is take the derivative of s. So s prime is negative 32t plus 16. And now we need to evaluate s prime at t equals 2. So this is negative 32 times 2 plus 16, or negative 48 feet per second. And it's good that it's negative because that means he is going down.